So we'll be doing an important topic today. The topic is completing the square, solving a quadratic equation by completing the square. It's one of the important skills in algebra, and I'll try to explain this in as simple as terms as possible because at times students get very confused while doing this. Now, there are one or two things that you need to understand. The first thing that you need to understand is that ex square plus bx plus c is equal to 0, a is not equal to 0. This is how a quadratic equation looks like. This is the general form of a quadratic equation. Please remember that. This A, B, C can be in capital, in small, that doesn't matter. So this is the first thing that you need to understand. Now, if I have to complete the square, so the first thing that you need to do is you are given any equation, you put this, the given equation in this format. So I'll give you an example. For example, if x square plus x minus 20 is equal to 0, this is the equation x square plus x minus 20 x square plus x minus 20 is equal to 0. This is a quadratic equation which is already in the journal form, in the standard form. In this equation, you might know that a is equal to 1, b is equal to 1, and c is equal to minus 20. Now, if the given equation x square plus x minus 20 is already in the journal form, then we can start the question. Then you are lucky that you got it in a journal form. But usually in exams, what teachers tend to do is they'll put the equation in a format like this. They might put the equation in a format like this. Uh, so you'll have to take care of that. So, for example, if the equation is m square minus 5m minus 3, then the general form would be m square minus 5m plus 3 is equal to 0. That would be the general form. 5x square is equal to 4x plus 7. This would be 5x square minus 4x minus 7 is equal to 0. So, uh, given a whatever quadratic equation it is given to you, you put that in the general form. Ax square plus bx plus c is equal to 0. Uh, so, this is the first thing that we need to take care. So, we need to understand what is the general form of a quadratic equation. Important thing that you need to understand. Okay. So, for completing the square, I'll be sharing a very simple thing that you can do. All that you need to do is add minus b upon 2a whole square to both sides of the equation after ensuring the coefficient, uh, the ensuring the x square coefficient is 1. So what is the meaning of this? So what you need to do is b upon 2a whole square. So this is what you need to add to the both sides of the given quadratic equation. So for example, in our case, let us take this simple case x square plus x minus 20. In our case, b is 1 and a is also 1. So what we need to do is 1 upon uh, twice of 1 would be 2. So this is a factor. This is a factor that needs to be added on both sides of the equation. Which equation? This equation. X square plus x minus 20 is equal to 0. So this factor, uh, in the quadratic equation, this factor 1 by 4 needs to be added on both sides of the equation. Another thing, if you see, he is talking about two things. One is this factor b upon 2a whole square to be added on both sides of the equation. The second is after ensuring that the coefficient of x square is 1. In our case, incidentally, the coefficient of x square is already 1. What is the meaning of coefficient of x square? Whatever number is there besides x square on the left side, that is called the coefficient of x square. In our case, the coefficient of x is 1. So this is the meaning of coefficient. So you need to ensure that before you start the process, you need to ensure that the coefficient of x square should be equal to 1. So let's start. So x square plus x minus 20, I'll add 1 by 4 on both sides. See, in an equation, because the equation is balanced, because there is equal to 0. So whatever you adding or subtracting or multiplying or division, same thing should be happening on both sides of the equation. you can't change the balance of the equation. Now, what happens when I do this? I hope you know the this algebraic expression, algebraic expansion x plus a whole square. So x plus a whole square is equal to x square plus 2ax plus a square. Now, what will be happening is that once you have added the coefficient, once you have added b upon 2a whole square on both sides, your left hand side should reduce to this x plus a whole square is equal to x square plus 2ax plus a square. It will definitely reduce. So you need to be confident about this, but then you will have to do a bit of manipulation. And that is where your skills of algebra will play a critical role. So now when I look at this, see the manipulation that I'm doing. So I'm doing x square plus x plus 1 upon 4. I have taken 1 by 4 together with x square plus x, and I'm writing minus 20 here is equal to 1 by 4. This is 1 by 4. Now see what I'll be doing to this x. Now this x can be written as twice multiplied by x multiplied by half. Uh, this is a symbol of multiplication which I use. This is the symbol of multiplication I use so that uh, my symbol of multiplication doesn't get confused with my x. So please understand that this is a symbol of multiplication. Now see, this is a critical step. Please don't get confused here. So this x can be written as a twice of x into half. Why we are doing this, you'll understand this in within few minutes. So again, so x square plus 2 into x into half plus this 1 by 4 can be written as 1 upon 2 whole square, and then this minus 20 I'll take on the right hand side is equal to 20 plus 1 by 4. Now see what, if you look closely what this is. This has become x square plus twice a, this has taken the shape of okay, this has taken the shape of x square plus 2x into a plus a square, where my a is equal to half. And what is this? This is x plus a whole square. So x square plus a square plus 2ax. So this expression is equal to x plus a whole square. So what is happening now is that x square plus 2x half plus 1 by 2 whole square, I can write whole of this in the form of x plus half whole square is equal to this 20 plus 1 by 4. So 20 plus 1 by 4. Now there are students who face difficulty in this also. Very easy to do. Write this 20 as 20 upon 1. Then you write this as 20 into 4 upon 1 into 4 plus 1 upon 4. This is 80 upon 4 plus 1 upon 4. This is 81 upon 4. So my right hand side is 81 by 4. So this is where I have reached after step 3. A few of you would find difficulty when you are doing this part. I request you to maybe rewind the lecture for about 5 minutes and see this step again, or be patient. We will be doing one or two more questions. So by the end of this lecture, you'll understand. So you'll have to be a bit patient when you are going through this, because first time this becomes a bit confusing. But I'll recap what we have done till now. The first thing that we have done till now is that we any equation, quadratic equation which is given to us, we reduce it into the general form. So that is the step 1. Let me write this as step 1. So my step 1 is, I'm given a quadratic equation, I reduce it into the standard form. I find my a, b and c. Then what is the step 2? Step 2 is, I'll add the value of b upon 2a whole square on both sides of the equation. So for example, in this case, my b upon 2a I identified my b, identified my a, then I added the value of b upon 2a whole square on both sides of the equation. My value of b upon 2a whole square was 1 upon 4. So I wrote it uh, 1, I added 1 by 4 on both sides of the equation. See, another thing that you can do is, if you are getting confused, half square is equal to 1 by 4. If you are getting confused, what you can do is leave it as 1 by 2 whole square. 1 by 2 whole square. So on the left side, you let it be as half square. See, this is if you are getting confused. On the right hand, you write it as 1 by 4. So then what you do is, you take this value, this b upon 2a whole square, in our case half square, closer to your x square and x. So basically now I'll focus on this only. And this minus 20 which was there, I've taken it on the right hand side, because uh, this minus 20 is not playing any role going forward. So by the step 2, by the end of step 2, this is where I have reached. Now in step 3, this is basically my step 3. In step 3, this expression x square plus x plus half square, I have to reduce this to this format, x plus a whole square. X plus a whole square is equal to x square plus 2ax plus a square. So basically, this middle term 2ax, this x has to be reduced in the form of 2ax, and this will require a bit of your skills in algebra. Then you'll be able to understand this well. So I have reduced my x as a 2x into half, because 2 and 2 will cancel and x is there. Now whole of this whole of this is equal to x plus half whole square. And on the right hand side, what is happening is that 20 went to the right hand side. So 20 plus 1 by 4, that is 81 by 4. So this is the end of step 3. Now comes step 4. Now x plus half whole square is equal to 81 by 4. Therefore, x plus half is equal to plus minus root 81 by 4. Uh, Let me explain this to you with a simpler example. You would have solved something like x square is equal to 81. So then we write this as x is equal to plus minus root of 81. And therefore x is equal to 9, basically plus minus 9. So these are the two values of x that you have. So similarly, if x plus half whole square is equal to 81 by 4, then x plus half would be equal to plus minus root 81 by 4. And therefore, x plus half would be equal to plus minus 9 upon 2. Why 9 upon 2? This is 9. Because root of 81 is 9, root of 4 is 2. So this would be plus minus 9 upon 2. Now, we'll have two answers. In first case, x plus half would be equal to 9 upon 2. In second case, we'll have x minus half is equal to minus 9 upon 2. So in first case, my x would be equal to 9 upon 2 minus half. So in first case, my x would be equal to 9 minus 1 is 8. 8 upon 2 is equal to 4. This is my first answer. X is equal to 4. So in second case, I'll have x plus half is equal to minus 9 by 2. By mistake, I had written minus here. So now x is equal to minus 9 by 2 minus half. X is equal to uh, minus 10. So x would be equal to minus 5. So the two answers that I have is 4 and minus 5. 4 and minus 5. So this is how completing the square would give us the answer. And now I want to show you that the answer that you got by completing the square is same as the answer you will get it using the quadratic formula, uh, the standard quadratic formula minus b plus minus b square minus 4ac upon 2a. And the same formula, if you can split the middle term, you will get the same formula. So all the methods, any method that you do for solving a quadratic equation will give you the same formula. One thing that, of course, one of the question you might have about completing the square would be that why do we require this completing the square method? This seems to be a very tedious method. You first do this step 1, then you do step 2, step 3, step 4, and finally you have the answer. Because I think if you have an idea, then this question x square plus x minus 20, x square plus x minus 20 is equal to 0 can easily be solved using the formula. The formula that we have is x is equal to minus b plus minus b square minus 4ac upon 2a. So I could have used this formula. So minus b plus minus b square 1 minus 4ac upon 2 4ac upon 2 1. So this will be equal to minus 1 plus minus root 80. This would be plus 81 by 2. So this will be equal to minus 1 plus minus 9 upon 2. So this will be equal to uh, minus 1. This will be equal to minus 1 plus 9, that is 8 by 2, that is equal to 4. And minus 1 minus 9, that would be minus 10. Minus 10 upon 2 minus 5. So you might be wondering, why didn't I use this method? Why didn't I use the quadratic formula to derive at this answer? See, the thing is that completing the square has its own use in mathematics. There are, for example, when you one of the uses that when we are completing the square, if you understand, going into a bit advanced topic. Each quadratic equation can be represented as parabola. Now, there are few things in parabola which becomes very obvious when you have when you are able to uh, manipulate the quadratic equation using the completing the square method. So you will understand that in class 11th. Parabola would be explained in detail. Then there is a topic called integration. In integration also, this completing the square is a very important skill. So the point is that completing the square is an important skill in mathematics. That is why it is taught. Otherwise, the quadratic equation can be used. The easiest way of solving a quadratic equation is using this minus b plus minus b square minus 4ac formula. Incidentally, this equation x square plus x minus 20, x square plus x minus 20, this equation could very well have been solved using splitting the middle term. So x square minus 5x plus 4x minus 20 is equal to 0. So x minus 5, x minus 5 plus 4 is equal to 0. X plus 4 into x minus 5 is equal to 0. X is equal to minus 4. X is equal to 5. So we could have used this formula. We could have used this method also, splitting the middle term. Also, we could have used the formula x is equal to minus b plus minus b square minus 4ac upon 2a. But I think you would have understood when I'm saying that completing the square is a necessary skill that we need to learn, because there are few topics in mathematics where you will require the this method. So that is why first time it uh, seems a bit difficult, but as you practice you learn more. And let's do one or two more questions so that you understand this method well. So let's continue. So let's pick a difficult one so that you understand the concept well. Let me pick this 9y square minus 12y plus 2. So 9y square minus 12y plus 2. Now this is in the standard form. So I compare this with ax square plus bx plus c is equal to 0. You can actually write this in terms of y also, doesn't matter. So please don't get confused. I can compare this with ay square plus by plus c is equal to 0 also. So doesn't matter. So a is equal to 9, b is equal to minus 12, c is equal to 2. So these are the values that I have. Now my first instruction is that I should add b upon 2a whole square to both sides of the equation after ensuring that the x square coefficient is 1. So I can add b upon 2a whole square on both sides of the quadratic equation after ensuring, see, I have to ensure that first my coefficient of y square should be equal to 1. So let me calculate b upon 2a whole square first. So this is b, so this is minus 12. Minus 12 upon 2 into a is 9 whole square. Now I solve for 2, 6, 3, 2, 3, 3, this is 4 upon 9. So 4 upon 9 has to be added to both sides of our equation after ensuring that the coefficient of y square is equal to 1. So how do we make this 9 disappear? We make this 9 disappear by dividing both sides of this equation by 9. What do we do? 9y square minus 12y plus 2 whole upon 9, and this is 0 upon 9. So now this can be written as y square minus 12 upon 9y plus 2 upon 9, and 0 upon 9 would be equal to 0. I hope you are able to understand this step. At times students face difficulty in understanding this step also. In case there is any doubt, please let me know in the comment section. I'll be glad to get back. But now what I have done is my coefficient of y square has become equal to 1. Now I have this factor of b upon 2a whole square, which is equal to 4 by 9. I'll add this 4 by 9 on both sides of the equation. So y square minus 12 upon 9y plus 4 upon 9 plus 2 upon 9 is equal to 4 upon 9. Now do remember that whatever factor that we have added, that will help us making the x plus a whole square thingy that we had done here. We had discussed here x plus a whole square. X plus a whole square is equal to x square plus 2ax plus a square. So this factor would help us make uh, the whole square term, uh, the new factor that we have added. So this factor which is already there, we can take this. This factor won't play any role in the process. Now we can take this factor on the right hand side of the equation. Now I look carefully here, and I have to, again, as I have told you earlier, this is very important to look at, because this has to be this will help me put this expression in this format. Let me use y here. Y square plus 2ya plus a square. This factor will help. Now, how do I manipulate this factor? See, this 4 by 9, and the hint that you can get is this y square will remain the same. This will be y square. This 4 by 9 is in the format of 2 upon 3 whole square. This 2 upon 9, as I have told you already, should be taken on the right hand side because it has no role to play on the left hand side now. Now, how do we split this? We split this while looking at this 2 by 3. So, the hint that I have is this can be written as minus 2 multiplied by 2 multiplied by. So, let me write this as 12. Actually, this is getting. You would have noticed that this 12 upon 9 can be written as 3 3s are 9, 3 4s are 12. So, let me write this as 4 by 3. 4 by 3 by. This will simplify the matters to a great extent. So this 2 by 3, 4 by 3 can now be written as 2 multiplied by y multiplied by 2 upon 3 plus 2 by 3 whole square. Let me do this again so that you don't face any difficulty. Let me do this again. Let me do this again. This y square is as it is. This 4 by 9 I know can be written as 2 by 3 whole square. This 2 by 9 I take it on the right hand side. And this minus 4 by 3y, I write this as minus 2 multiplied by y multiplied by 2 by 3. So 2 into y into 2. So 4y upon 3. It is the same as it is written here. But now the magic which has happened is that this can be written as y minus 2 upon 3 whole square is equal to, this is 9, 4 minus 2 is 2. So now this can be written like we had done previously. This can be written as y minus 2 upon 3 is equal to plus minus root of 2 by 9. And this can be written as y minus 2 upon 3 is equal to plus minus root 2 upon. See, root 2 in the numerator would be root 2, but in the denominator root 9 would be 3. Now I have two answers. First answer would be y minus 2 upon 3 is equal to plus root 2 upon 3. Y minus 2 upon 3 is equal to minus root 2 upon 3. So y is equal to 2 upon 3 plus root 2 upon 3. This is y is equal to 2 upon 3 plus root 2 upon 3. So this can be written as 2 plus root 2 upon 3. And this can be written as, I made a mistake, yeah, this is minus root. This is minus root. So this would be equal to 2 minus root 2 upon 3. So these are the two answers that I have. These are the two answers that I have. Let me do another question so that you understand this well. See, in mathematics, again and again, the more you practice, the more you understand. So the better you practice, the more and more questions you do, the better you will understand. Let me do another question. This one, 2y square plus 9y plus 10 is equal to 0. So 2y square plus 9y plus 10 is equal to 0. So again, I have to add the coefficient of b upon 2a whole square on both sides of the equation after ensuring that the coefficient of y square is equal to 1. So let's identify our a, b, c first. So this is my a, this is my b, this is my c. So b upon 2a whole square is equal to 9 upon twice of 2 whole square. This is equal to 81. This is 4, this is 16. So the factor that I have to add on both sides of the quadratic equation is 81 by 16. So b is 9 Twice of a is 4, 4 square is 16. So 81 by 16 has to be added on both sides of the equation after ensuring that the coefficient of y square is equal to 1. How do I ensure that the coefficient of y square is equal to 1? I divide both sides of the equation by 2. So 2y square plus 9y plus 10 whole upon 2 is equal to 0. This would be equal to y square plus 9 upon 2y plus 5 is equal to 0. Now, this is what I wanted. My coefficient of y square should be equal to 1 before I start the process. Now, I have to add the factor of 81 by 16. So, y square plus 9 upon 2y plus 81 upon 16 plus 5 is equal to 81 upon 16. So I've added the factor 81 by 16 on both sides. And then, as I've told you before also, see, I get a hint when I look at this 81 by 16 factor, because this can be written as a 9 upon 4 whole square. This 5, which was originally in the quadratic equation, will play no role on the left hand side of the equation. So that is why I'm recommending you take this on the right hand side, because its role, there's no role that it plays on the left side of the equation. So 81 upon 16 minus 5, I've taken it on the right hand side. Now I need to split this 9 upon 2y. I'll get a hint from this 9 by 4, so I can write this as 2 multiplied by y multiplied by 9 upon 4. So 2 to the 4, 9 by 2y. And now this whole can be written as y plus 9 upon 4 whole square is equal to 81 upon 16 minus 5. So I need to solve this 81 upon 16 minus y, minus 5. Let me solve this. This can be written as 81 upon 16 minus 5 into 6, 80 upon 16. This would be equal to 1 upon 16. I'm just taking LCM. So this is equal to 1 upon 16. Now I'll get the answer, because this can now be written as y plus 9 upon 4 is equal to plus minus 1 upon 4. This is y plus 9 upon 4 is equal to 1 upon 4. So y plus 9 upon 4 is equal to minus 1 upon 4. So y is equal to 1 upon 4 minus 9 by 4. Y is equal to minus 9 by 4 minus 1 by 4. So y is equal to 4 upon minus 8. Y is equal to minus 10 upon 4. Y is equal to minus 2. Y is equal to minus 5 upon 2. So this is the final answer. This is the final answer. So now I hope you will be able to do rest of the questions, and I've tried to make this as easy as possible. So we solved 3 examples in this lecture. Uh, Finally, I'll just take you through the steps again. Know the standard form. Standard form will help you get your ABC. Step 2 is b upon 2a whole square. This b upon 2a whole square has to be added on both sides of the equation. But ensure that the coefficient of x square is 1. So add that. This b upon 2a whole square will help you split the x form, the x term will help you split the x, will give you basically a hint how to split the x term. And then you will reach a step like this: x plus half whole square is equal to 81 by 4. And then x plus half is equal to plus minus 81 by 4. Once you have reached this step, once you have reached this step, then more or less the question is done. So for example, in the first question, this is the step that we got. In the second, question, this is the step that we got. This was the step. This was the step. At y minus 2 by 3 whole square is equal to 2 by 9. So this is the second. In the second question, this is the step. Once you have reached this step, then the solution is within your reach. In the third question, this is a step where we know that we are very close to the solution. Another thing that we discuss, which is very critical for you to understand, is that the answer that you will get using completing the square would be equal to the answer that you will get when you use the quadratic equation formula, would be the same if you are able to split the term also. The answer will not change. Answer, you use any form method to solve the quadratic equation, the answers would remain the same. So finally, I hope this was useful for you. Please practice the question, try to do more and more questions. Like the lecture, subscribe to the channel. I have more than 2500 videos uploaded from class 6 to class 12. And let's meet in the next lecture again. Thanks a lot for watching.